So I'm going to get started. This is a fairly in-depth presentation, so there's a lot to cover. So I'm probably going to use a good chunk of the time. I'll leave a little bit of time at the end for questions. So a little bit about me. My name is Les Hazlewood. I'm the Stormpath CTO. We offer a identity and access management and control API. We're fundamentally a REST JSON API. And we operate as a cloud SaaS provider. We also have an on-premise distribution as well. And we're security guys. In addition to this, I'm also the PMC chair of Apache Shiro, which is the Apache Software Foundation's open source security framework. So if you have any questions as it regards security, specifically with REST APIs, feel free to talk to me at the end of the show or at the end of the presentation, and I'm happy to cover whatever I can. So we have a fairly detailed outline. There's a lot to cover. But don't worry, each one of these things can be covered in a couple of minutes each, so it might look a little bit cluttered, but there's actually a lot of information that's really beneficial if you're developing a modern REST app, and we'll cover each one of these bullet points as we move through. So we're really here to talk about APIs, and when I say APIs, I mean something that a developer can consume that to leverage, particular behavior outside of their system. And so with that in mind, I really want to focus on pragmatic approaches that are convenient for developers. So you're building applications, you're a developer building an application. We want to make a REST API and utilize design principles that make it easy for developers to consume these APIs. So the developers are our primary customers, whether they're internal or external. You want to make it easy for them to use, easy for them to understand. And so how many people here have heard of the term Rastafarian? Okay, so for those that if you haven't heard the term, a Rastafarian is an ideologue. There's somebody who really sticks to the letter of the law as REST is prescribed by a certain inner circle of experts. And if you do anything outside of that inner circle's recommendations, then you are, you're forbidden to interact with them at a human level. I don't know. They're nuts about REST and making sure you do things perfectly. I'm not a Rastafarian. I am a pragmatist, and so there are some things that I will talk about that kind of diverges away from things that Rastafarians really care about. That being said, I am also it's also very important to me to stay true to Dr. Roy Fielding's thesis and some of the core principles of why REST and RESTful architectures are really important. So I'm not going to veer too far away from best practices. But we do want to focus on adoption, making things easier for people to consume the API so that they can adopt your service. And we'll also focus on scale. How to do things to allow many different heterogeneous systems to consume your REST API so it can be ubiquitous. So why REST? Why are we here talking about REST? Dr. Roy Fielding, when he wrote his PhD thesis on RESTful architectures, talks about these 6 bullet points specifically as the reasons why RESTful architectures exist or why it's a good idea. The first is scalability. And when I say scalability here, I don't mean scale from a performance perspective. I mean scale from an internet scale perspective. Having things be ubiquitous so any client technology, any programming language can leverage these things. That's the internet scale that we're talking about here. REST is also very general. It can be used to satisfy many different requirements and use cases. So there are a lot of really good benefits for generality in the REST paradigm. It's independent. I can have a server written in Java, a server written in PHP or Ruby, and they can all communicate with each other using the same RESTful protocol. So you have independence from implementation level semantics or details. Latency is also something really important that Fielding talks about in his thesis, specifically with regards to caching and HTTP caching, and it's often overlooked when people talk about RESTful architectures. So we'll cover some techniques that are beneficial to caching. Security is also built into the HTTP specification in the form of the authorization header, so you can leverage existing security mechanisms. And encapsulation is important. I can have a RESTful API that exposes data in a particular way that I want to expose it, but it doesn't have to expose everything about my system or maybe some of the internal workings or the details of data or some of the resources. So these 6 properties are why Fielding created his RESTful thesis, and they're really important, and we'll talk about all the properties that kind of help these things come to fruition. Why JSON? So this is a REST JSON-based presentation. Why is JSON so popular? It's ubiquitous. Something like 55 of all new application development includes some form of JavaScript. It's simple. The grammar, actually, for JSON is very easy to consume. It's easy to parse for tools, and it's easy for human beings to understand it. So it's very readable. It is also scalable in a use case sense. You can have JSON represent just about anything. It's just a bucket of name-value pairs. So it's very flexible in providing you a data mechanism that allows you to represent almost anything you want. So JSON's really important these days. And also, one of the things I want to stress in this presentation is XML has sort of been the dominant language in the past for kind of REST-based APIs, and JSON's sort of taking over. It's a little more simple. A lot of people like to consume it. It's easier to understand for most people. So that's why we see some of the shift to JSON. How many people have heard of this term HATEOAS, HATEOAS, however you want to say it? This is a convoluted term. You can call it an acronym, I guess. It stands for Hypermedia as the Engine of Application State. And this is what the Rastafarians are really, really keen on communicating. And it is actually a very important concept. And the idea is that if I interact with a REST API, I should be able to discover and find out everything I need to about that API just by interacting with the API server. So if you picture yourself or think of yourself as a web browser, when you go visit a homepage for a particular website, you can navigate to all different parts of that website. You can interact with functionality. You can see many different resources. The browser knows nothing about the format of a lot of this stuff, but it does know how to consume data types that it understands, and it knows how to traverse links. And so this is really important for RESTful architectures, linking and the ability to reference other resources. So this is sort of more of a HATEOAS is more of a restriction, a further restriction on RESTful architectures. You can be RESTful without strictly adhering to HATEOAS principles, but this is sort of the purity, the letter of the law kind of approach. We'll talk a little bit about how these things apply later on. So we're just talking about REST. HTTP has been around for forever. JSON is very simple. It's an easy grammar. People understand it. Therefore, REST must be easy, right? JSON's easy. HTTP's easy. It's got to be really simple. And that's mostly true for a consumer of a REST API. The problem is that for providers, REST is really freaking hard. There's a lot of intricacies, a lot of details involved in producing a nice, clean REST API. And the reason why is that REST is not a standard. There's no RFC for REST. There's no W3C standard. There's no specification body behind it that's formalizing how to approach it. REST is fundamentally an architectural style. It's a way of solving problems via patterns that is not formally codified. And because that's the case, you get a lot of people that interpret things differently. You know, I might want to represent a link differently than the way you want to represent a link. And there's a lot of debate on the public internet about how things should be done because there is no standard. That being the case, we're here to talk about the things that make life easy. So we're going to talk about guidelines or common conventions or de facto standards that will make your lives really easy. So things that have been vetted and proven and tested by a lot of other companies are really going to be represented in this presentation. So where things must apply according to an HTTP specification, I will let you know. Everything else in this presentation is really a collection of best practices and standards. It's pretty opinionated, so we might not have total agreement, but this is really an accumulation of a lot of research that we've done over the last couple of years while we've developed our own REST API. So that being said, I just want to bring up Stormpath's domain very, very briefly, if only to mention these things because the rest of the code samples in this presentation are going to be based on actual code that we execute at Stormpath. And so at Stormpath, we manage user identities, groups, mappings between these things, the associations between these various things. Applications have access, or users have access to groups which have access to applications. These are all things that I think most people in this audience understand and are comfortable with. So we're going to see a a lot of examples using this stuff. But let's just talk about some fundamentals first before we start talking about various design issues. We really want to focus in RESTful architectures on resources. And a resource is a noun. It's not a verb. Something like an account or a directory or a document or a video. These are all things that you can represent via nouns. Verbs or behavior are not represented in a resource. We also want to make sure that resources are coarse-grained, not fine-grained. So I might have an account resource, but it would probably be pretty silly to have an account password resource. Right? The password's extremely specific. It's a single property. But the account resource is general. It can be used in many different scenarios. And the reason why this is important is that people consuming your REST API will come up with use cases and have needs that you could have never have foreseen when you've written your REST API. So by keeping your data objects coarse-grained, you will satisfy a lot of conditions that you have never planned for. And it will be easier for them to use your service, and it'll be easier for them to consume it. And it really helps with longevity of your service over time. And so let's talk about why we want to focus on resources instead of just verbs. What if I had an API with URLs that did embed verbs in them? Maybe I had a get account, or I wanted to access an endpoint called create directory whenever I was creating a directory, or I want to update a group, or verify an account email address. This doesn't look so bad. There's only 4 of these things up here. But the problem is that as behavior starts to accumulate, you might end up with this, or much, much worse. Maybe if I had URLs to get all accounts, or update a group's name, or search groups by name, or verify whatever. The point is that as behavior changes, or as you add new features, the number of endpoints that you would have to support will explode if you use kind of a pattern like this. This smells like the old, bad RPC from the late 90s. Don't do this. This is not a good idea. Don't include this stuff in your API. There is a cleaner way. And so we'll talk about what that is. We just want to keep it simple. There's really only 2 things that we have to worry about, or 2 ways of representing information in a REST API. There's fundamentally a collection of resource and an instance resource. And an instance is kind of what you would think it is. This is a Java conference. So if I had a class and I create many instances of it, a resource or instance resource represents the single properties of a single instance. A collection resource is something that represents multiple instances. And it's important to note here that I didn't call it just a collection. I'm calling it a collection resource because it itself is its own resource in a REST API. It can have its own properties in addition to the things that it contains. And so if it has its own set of name-value pairs, it is itself a first-class resource citizen. And I'll show some examples of this in a little bit. But these are really the only the 2 things that we have to worry about. So a collection resource kind of looks like this. This is a URL endpoint that, it says /applications. It doesn't say /application, it's plural. So the thing that we've seen that we think makes the most sense and that is easy to consume is that you name your endpoints in the plural because they do represent multiple things, 1 or more things. It's not /application because I'm not interacting with a singular entity. I'm interacting with multiple entities or multiple resources. And typically, by convention, individual resources usually hang off of the collection that they're a child of, or that owns them. So an instance resource might be accessible in a URL like this, /application /some ID. So trailing / on the collection resource, it's not necessary. There's no need for it because, again, and this is kind of important, this is itself a first-class citizen resource. And so if it has its own properties, its own collection, or its own items array that we'll talk about in a little bit, it is its own resource. So just as you wouldn't, this is a resource just as this is a resource. So there's no need for a trailing / at the end of it. You can put it there. It doesn't really hurt anything, but it's not required. Or at least I don't think it should be required. So we've talked about resources, collections, instances. Now we want to start talking about behavior. And in the HTTP specification, there are 5 kind of well-known behaviors attributed to the spec. Get, put, post, delete, and head. Head is a metadata operation. I just want to get some information about a resource, but don't actually give me the resource back itself. The other HTTP verbs are the way that we can perform behavior on those resources. But there is something important to note here. A lot of people think get, put, post, and delete have a one-to-one correspondence with read, update, create, and delete. And that is not true in the HTTP specification, or at least it's not true according to the spec as far as how the verbs operate. There is not a one-to-one correspondence between these things. And I'll explain where those differences lie. As you would expect, however, get, delete, and head really do exactly what you think they do. They have a one-to-one correspondence with the behavior you would expect. Get is actually a read. Delete is actually a delete. I want to remove a resource. And head is, as I said, give me some metadata about the resource. I don't want the actual resource back itself. But put and post aren't obvious. They can be both used for create and update. Both scenarios are possible with these two verbs, but in very specific, under very specific conditions. And I'll give an example, some examples of what they are. So you can use put to create a resource, or you can allow your clients, rather a REST client, to create a resource using put if the client knows the ID that they want, where they want this resource to be stored. So if you allow your clients to generate their own identifiers, maybe it's a property name, maybe it's a username, for example, that shouldn't change for an application, you can allow this. And this is totally legal. And the idea is that the client knows where they want this resource to be stored, and so you can use put to do that. Put can also be used for update if you specify all of the data when the put is executed, when that request is executed. The issue with put is that it must contain all of the properties. Puts cannot be used for partial updates. And this is, as I said, I'd mentioned, this is not a convention. This is actually mandatory by the HTTP specification. And the reason why is that puts must be idempotent. And an idempotent operation is any operation that could be performed once or multiple times and result in the same server state. It's really important to note here that idempotency is a property of server state, not necessarily client state. So as long as the server state is the same between multiple requests, then the property of idempotency is maintained. And so this is really important because going back to this example, let's say on request A, I specify only the name, and then some other client specifies, and on request B, I specify just the description, just partial information. In between request A and B, there could be another client that specifies the name. And so at the end of request B, now my resource has the other client's name but my description. So because the server state isn't the same after request A and B, that's not an idempotent operation. You have to guarantee idempotency for HTTP. And so that's why put must include all the data. You have to include all the attributes or all the data for a put resource. So again, put must be a full replacement operation. Post, however, can also be used as create, and this is typically done on a collection resource, and you're going to sort of add a child to that collection resource, and you're allowing the server to generate an identifier because you might not know what it is when you interact with the server. And so in this case, we're calling a post with a payload on the application's endpoint, and if this is successful, we're going to get a 201 created, not a 200. This should be a 201. Again, this isn't mandatory, but it should be a 201 to let the client know not only was your request successful, but I also created something for you. Oh, and here's the location of where that thing resides, by the way. So you do want to set the location header as a response header when a create goes through successfully. So they can see not only was the request successful, but I created something, and here is the location of where that thing resides. And so at least in Stormpath's API, we always return the fully qualified canonical URL of where that thing resides. So clients can just take that URL and immediately execute a request for it if they wanted to. So that is post as using post to create resources. You can also use post as an update mechanism as well. And here you see that we're actually putting some data to an existing URI, and we're specifying, in this case, just the name property, and we're getting back a 200 OK, stating that the request went through successfully. And the interesting reason, or the interesting thing here, is that this is totally legal. Post does not have to be idempotent. It's the only HTTP verb in the HTTP specification that does not require idempotency. So you can use post for partial updates. Puts must be full updates. Posts can be used for partial updates. There is an RFC 5789, that is trying, or at least trying to cover this notion of a patch verb to be added to the HTTP specification. It's sort of stagnated for a while. I don't know that it has a lot of leverage behind it, because as I've just demonstrated, you can do partial updates with post as well. And so because it's possible today, there doesn't seem to be a whole lot of drive to get that out of the spec committee. But it's out there if you want to go look at it. It's RFC 5789. So verbs, nouns. The other thing that I want to cover briefly is this notion of media types. And this is really important in RESTful architectures. A media type is basically a format specification associated with a set of parsing rules. So clients know how to interpret or respond to the data format. The clients can tell the server what they want using the accept header. So if the client says, hey, my accept header is application/JSON, they're telling the server, hey server, when you process this request, I would like you to give me JSON back in response. And the server will set the content type header on the response to say, I know what you requested, but here's what I'm actually sending back. Most of the time we hope they're the same. You know, if the client requests JSON and the server responds with JSON, these two values should be the same. But you can also do kind of preferential ordering with accept headers, so the client can specify, not only do I accept JSON, but I also accept XML and plain text and all sorts of other things. Then the server can then leverage that header to return a very specific resource type back to the client, if depending on the client's desires. So here's some, at the bottom, some representations of typical resource or media types. Application/JSON is the one that everybody's familiar with. You can also start creating custom media types, though, and here's just some examples. There's many ways to define these. Application/foo plus JSON says not only is this a JSON document, but it's also a JSON document according to the foo specification. And you can also provide kind of parameters, you know, via the semicolon and ampersands to provide additional information about the content contained within the body. We'll talk more about media types and how to leverage this specifically for versioning in a little bit, but this kind of gives you an idea of media types. Okay, fundamentals are covered. Let's get into some design. Now, it's really important to know in RESTful architectures, what your URLs look like don't really matter a whole lot, and they shouldn't matter as far as clients and servers interacting with each other, but they kind of matter to people. So it's also often one of the things that people talk about when they're designing their REST APIs. What does my base URL need to look like? So again, while it's not really important for the technology, it is kind of important for people to kind of wrap their heads around, how do I start? And so if you're designing a REST API, which of these two things do you think you would prefer to consume if you're yourself a customer? You know, it's pretty obvious that everybody favors the top URL. And the reason why is that the bottom one, you don't really know if the REST API is an afterthought, or is it supposed to be, you know, some kind of location that's buried within some website. And it's just, it doesn't look very clean. It doesn't look like you're catering to my needs as a developer who wants to consume something user-friendly. The top one clearly communicates that, hey, you know, this is where you have to go for REST APIs. We have you covered, and we hope it's easy to use. So, of course, APIs don't matter that much, but if developers are your customers, you're going to want to make them happy, and so you should support the smallest URL possible. It inspires confidence. Some questions that we receive sometimes are, if a browser versus a REST client visit the same exact URL, what should happen? So in some cases, if it's a REST client, I can return back just JSON. But if it's a browser and the client represents a human being, maybe I can return a full-blown HTTP page, or excuse me, HTML page that renders completely in the browser and shows images and all these really good things. That's a totally viable approach, and you can do that via content negotiation. You know, the server knows what type of format to return back. It seems to be, though, that the convention is to not do this, is to not show different types of format. And I think the reason why is that sometimes when you're a developer and you're hacking around with a service and you just want to test things to get it to work, you want to see the content that's coming back from the server. So maybe my REST client doesn't work correctly, and I just want to open up a browser and just execute a request really quickly to see if I get back something that I can visually parse. And so you can negotiate different types of content. In the Stormpath API, we've actually kept them the same because we feel it helps developers while they're debugging, and they feel comfortable knowing what they're understanding what they see, what comes back from the server. So we recommend that you keep them the same, but there's no strict mandate that you should do that. Okay, so with URLs, how do I handle versioning? If I'm going to upgrade my API over time, I don't want to break existing clients. And so how do I do that in a way that's going to make life easy for people? So there seems to be two dominant approaches. The first is that you actually embed the version number in the URL. And this is by far the most common approach on the public internet, especially with SaaS services. And the other way to do it is via a media type. And I'll explain the two different, I'll compare and contrast them. The top one is definitely easier to consume. If you don't know much about REST or media types or HTTP or all this other stuff, you know that if you at least put that thing in a browser address bar and hit enter, you're going to see something, or at least you should, or you might be able to. The bottom one is probably much more correct from a RESTful perspective, in that everything that's needed to understand the resource is encoded in the media type or the media type representation. So the bottom one says, this is an application, this is a JSON app. Well, actually, I got the JSON and the foo tokens swapped by accident, but if it was application/foo plus JSON, that says this is a foo JSON document that represents an application. Oh, and the version of this resource is at version 1. So the data that comes back can be parsed according to version 1 rules, version 1 semantics. The reason why this is really nice is that everything that needs to be negotiated between the client and server can be captured in the headers or as the media type, and then the URLs for your app actually never need to change, which can be very nice depending on the client or depending on the code that you write. So if I visit a URL today and specify version 1, and then I do it a year from now and specify version 2, none of my URLs need to change, none of my code needs to change. That's a really nice benefit. The trick or the difficulty with this approach is that not a lot of people know how to do this, not a lot of people leverage it in their server-side implementations of REST APIs, and it definitely requires some kind of solid understanding of what media types are and how to leverage them. And so if you have to support REST APIs for people of varying degrees of skill or education, like maybe there's, some of your customers are coming right out of high school and they need to consume this stuff, they might not understand what this is nor how to formulate a request. So if this is really hard for them to build up when they're trying to interact with your REST API, they're just not going to call it. So if your business depends on people calling your API for customers, it's really hard sell to go the bottom, albeit probably more correct approach. The top one is a lot easier to use and get running right off the bat. So Stormpath, we actually use that top URL as our base. And most other SaaS providers use that same technique for the same reasons. So this is kind of where we're kind of diverging from ideology in favor of pragmatism. Resource format, we've talked about this already. You can customize media types or media type representations. So the recommendation here is that start off with application/JSON. That's what everybody understands. It's easy to use. How do you parse custom data or media types, and how do I specify version attributes or other things? That's a lot more complicated. So we recommend that maybe you support this stuff when time allows. You start with the top one, and then you add these custom media types as necessary, as you have the ability to do so. Okay, media types, done. Another thing I want to bring up is camelCase. So when you're returning JSON documents or consuming JSON documents from clients, I just want to reiterate that the JS in JSON means JavaScript. And so you should see things like myArray.forEach, not myArray.for_each, right? This is not RSON, it's not Ruby object notation or RON. This is JavaScript. So keep these things consistent. And the reason why it's important to maintain this convention is that if you do have a JavaScript client, a web-based client that's running in the browser, for example, maybe it's an Ember client or Angular or something like that, they will be able to start consuming properties immediately off the JSON object because this is expected in JSON. They don't have to escape the property by quoting it, for example. So this facilitates integration. It keeps things easy to understand for people who understand JSON. So stay consistent. Dates and times. This is an interesting thing. I've seen a lot of different APIs represent timestamps and dates in many different ways. And really, there's no reason to do that. There is a standard. It's been around for a long time. It's called ISO 8601. So you should use it. This timestamp exists, or the specification rather exists to specifically represent text encoded times and dates and timestamps. So if you keep all of your timestamps in your API, ISO 8601 formatted, then any number of tools will be able to consume this very easily. Basically, every client language that I know of knows how to consume an ISO 8601 timestamp. So keep things consistent, use the standards, and integration will be a lot easier for your customers. Okay, so media type, camelCase, dates, hrefs. I just want to touch on this briefly. One of the most important things about RESTful architectures is this notion of distributed hypermedia. Fielding said it's absolutely paramount. It's one of the most critical, if not the most important part of RESTful architectures. And the idea is that resources need to be able to reference other resources. This is what makes the web work at a global scale. I can reference a link on Google's website just as easily as I could on Yahoo's. And I have the ability to reference these links and then traverse the links and maybe traverse very large content graphs. And it's this notion of linkability or distributed hypermedia that makes this possible. And so you really want to retain this property or this behavior in your REST API. And so hrefs are super important. You want them to exist in your body content so clients can know how to interact with other resources. And linking is very critical, as I just said, but it's kind of tricky in JSON, and I'll cover that in a little bit. It's really important though, so we'll dive into that in some detail. But in this case, you'll see in Stormpath's example, every one of our resources that's returned from our server always has an href property with a fully qualified URL. It doesn't need to be fully qualified, but ours is because we feel it's easier for clients. They can immediately consume the string and immediately execute an HTTP request without having to worry about how to construct the host and what port to communicate with or any of that stuff. So again, the name of the game for us is make things easy for customers, easy for clients. So all of our URLs are always fully qualified canonical URLs. Question in the back? No? Okay, awesome. So response body. Some questions we've had is, whenever I create something or I update a resource, or I create a new resource in the server, what should the response look like? Should I get that back? Should it be empty? Should it be some sort of success message? One of the things, get is obvious, right? If I'm executing an HTTP GET, clearly I want something back, so give it to me. But what about post? If I do post into the server, should I get that same data back or some other status? The thing that we believe is a best practice here that we've seen that works very well is that if I'm going to post an account, you should theoretically give me that account right back to me. And the reason why is there might be some data about it that the server changes. Maybe it applies a last updated timestamp or whatever. But if the server regurgitates that right back to the customer knows that when they consume it, they always have the freshest, most recent, most accurate version of that particular resource. And then they can either cache it locally or they can use it for other things immediately. But we found that this approach makes things easier for the customer or the client, specifically a REST SDK. If you're ever building a REST SDK, you know that whatever response comes back is immediately available and can be used and consumed or put into a cache. So it keeps things consistent. If you always know to expect it, it makes client code specifically much more simple. You can, however, specify control parameters, query parameters to override this behavior. And a good example of when you might want to do this is, what if I upload via a post a 10 gigabyte video file? Right? It'd be absurd for the server to spit that same video file right back out to me. Right? And so if you want to allow customers or clients control of this behavior, you can support these kind of override flags like underscore body equals false for the client to say, I get it, I know you usually give this stuff back to me, but in this case I don't want it. So that's one approach. Why the underscore? So the reason why, this again is a convention. In our experience, typically things that start with underscore or perhaps underscore reflect meta operations or things that are specific to the server or the implementation about how to communicate with the server, whereas things without underscores typically represent fields or data that's actually part of the actual resource. And so you want to separate what's part of the resource versus what is a control parameter, and you don't want to get them confused. So that's why we use an underscore in this case. Content negotiation, I covered this. I don't have a whole lot of time left, so I'm going to skip over it. But again, the client can tell the server what it wants, and the server can spit back the content and set the content type header. I will mention that the client should represent what it can consume as a comma delimited list in the order in which it prefers to receive the feedback. So in this example, the client saying, I accept both JSON and plain text, but I prefer JSON because it's listed first. And so the server can look at that and then render content back according to what the server supports based on the preference. We see resource extensions sometimes on actual URLs. And by convention, this conventionally overrides the accept header. So if a client says, hey, give me application/XML, but you see .json on the resource URL, you should return JSON back. And the reason why is that the URL is ultimately the most important part of the overall request, and so it trumps or it's more important than an accept header, at least by convention. Okay, how do we do linking? This is super important, especially for REST scalability. I said it's paramount, blah, blah, blah. It's tricky in JSON though. The difficulty here is that there's no standard for this stuff. There's no linking standard or specification in the JSON grammar. But there is an XML, right? XML has it. These things are known as X-links. The W3C has a standard for anchors, which is a type of X-link. The A element. So we've seen this many times before, and there's existing standards, so it's not an issue for people who do XML or HTML. But JSON does not have such a standard, so how do we do this? So for example, let's say I'm getting an account, and in Stormpath system, all accounts reside in directories own accounts, if you will. So what if I want to get back an account, and I want to get back its parent directory? These are two separate resources. How do I represent this in JSON? And there's a lot of ways to do this, by the way. There's, I think, HAL, H-A-L, is one of the JSON specs, or supposed spec. It's really a bunch of community members getting together to say, hey, this is how we like to do links. So there's HAL. I can't remember. There's a bunch of competing ways to do this. And the one that we settled on that we feel is the best, actually, and I'll give you a reason why, is that we simply have a link be a complex object that has a single property called href that references the fully qualified canonical URL. And the interesting thing about this is that if you look at it, it's not complicated. Even if you don't know what links look like or other these specifications, you can look at that and immediately know that, oh, I have to go somewhere else to get the directory. I have to go visit that href. But what's kind of interesting about this is in the X-link specification, there's this relationship attribute, or REL, REL equals help. The relationship indicates the type of link or why that link exists, maybe to get some contextual information around why the link exists. And the interesting thing in JSON is that's sort of implicit already by the fact that you have an attribute named directory. So the actual JSON attribute name itself can be used as the relation attribute that might exist in the X-link or W3C standard for XML, for HTML. So it's kind of cool in that now I have a relation and I have a URL. This is fundamentally what anchors present in HTML, and so you can encapsulate everything very trivially. The HAL specification, for comparison, by the way, has a separate property in the JSON document called links, and it's an array of links that have an actual rel attribute and an href attribute. And so all the links for a particular document would be collapsed into a single array property. And we don't really like that approach. In our opinion, and a lot of the engineers I've talked to, it requires you to scan different parts of the document. It requires you to have to go and switch context to understand where this information might go or might be linked to, as opposed to being in line or being more contextual with the data that's already there. And one of the really cool things about this particular technique is that it makes things brilliant when we talk about resource expansion or entity expansion that I'm going to cover very briefly. And I'll come back to this to explain how that works. Collection resources can work the same way. You can have, in this case, show me all of the groups that are assigned to that particular account, and that's just a normal href as well. You could provide additional metadata, like a media type property that says, not only is this a collection, but this collection contains elements that are of this type. That would be really nice, and that would make things a little easier for people to consume the REST API, or the REST API. So, okay, let's talk about REST or reference expansion. This is also called entity expansion or link expansion on the public internet. All three things mean the exact same thing. So the issue here is, what if I, what am I skipping through? There we go. So what if I want to get the account and its directory? I want to execute a single request, and I want both of those resources to come back because I don't want to have to execute 2 round-trip requests. It's inefficient, and I already know the data that I want to display. Perhaps maybe I'm writing a user interface. And so you can support this notion of an expand parameter that references one or more of the links or the attributes that should be expanded inline and returned back to the client. And so in this case, the client is saying, yes, I want the account, but I also want you to give me the directory fully expanded or materialized, if you will, inline. So when I consume the doc, I know that I have both resources. And so the reason why the linking technique that I just mentioned is really elegant is that if you notice, it's the exact same structure as what we looked at in the link scenario. The only difference is that it now has more properties. And so the beauty of this approach is that the client doesn't have to have special logic. It doesn't need to say, is this materialized yet, or is it not materialized, or do I need to go to another part of the document to find a link array and then expand those things as necessary, and which one do I expand? It's all self-contained in the same location as the actual link was previously, and it's very easy for a client to tell. Do you have a single property? If so, you're a link. If you have more than one property, you've been materialized, and I have all the data I need. Very simple coding-wise for clients to consume this information. So anyway, that's entity expansion. You can also do partial representations. Maybe if you do rate limiting or quota-based limiting of REST APIs, clients can maybe specify if you want to support this. I know that there's this huge document, but I only care about these 4 fields or 3 fields because these are the only things I'm showing on my current UI screen that I'm building. So this is a way that that allows you to support customization for your clients if they want to, engage or leverage this type of behavior. In this example, you see the client wants an account, but they only want the given name, the surname, and the directory's name to be returned in the response. And then you would just see those 3 things materialized in the result. Whether or not you want to support this is totally up to you. If you have to support rate limiting or whatever, it might be useful. Pagination, how do you handle pagination? There's a couple ways to do this. The most common one seems to be this notion of an offset and a limit parameter in most APIs. And so the idea is that I'm going to interact with a collection resource, right? We said /applications was itself its own proper resource. And so I will also specify maybe an offset parameter and a limit parameter. And what these two represent is offset is the position away from the 0 index of where you want the results to start. And the limit parameter restricts the number of results that are returned. And so this says, maybe if there's 25 elements per page, I want to start consuming on the 3rd page and give me 25 records so I can show the 3rd page. So this is great, and you can support pagination techniques, and the next result can say offset equals 75 and limit equals 25. And you can keep kind of consuming these different pages of the collection. But it might also be nice in true HATEOAS fashion, where the client doesn't need to know how to calculate those or build those URLs and do the math to figure out what represents a page or not. You can provide sort of nice, convenient link URLs. So in this is an example of a collection resource of all the groups assigned to that particular account. And as I said before, it's a first-class citizen resource. It's got its own properties, offset, limit, and now it's have some additional properties. The first page, there is no previous page because it's null. The next page and maybe the last page in the collection. Oh, and these are ellipses, by the way, just so I could save space. They're not actual dots or anything like that. So you would assume that these would be expanded. And then finally, the items array could either have a collection of links that represent the elements of that current page, or they could be fully expanded, to contain the actual elements in the collection. So that's why we call this a collection resource, because it does have its own properties in addition to the items that it contains. Okay, so moving on, many-to-many. I've got an account, and it can have many groups, but I can also have a group with many accounts. So how do I represent this many-to-many relationship in a RESTful architecture? And the idea is that, again, we want to work with resources. So if you create a resource that represents this mapping, like in our case, a group membership, now you actually have an entity that represents these two individual things. And so, like every other resource, it itself has its own location, its own fully qualified href, and then it's got links, or at least references to the account and the group for which the relationship is maintained. And the reason why we've seen a lot of other people do this, and we also did this in our API, and we feel it's a best practice, is that the relationship itself might have very useful information depending on your use cases. So maybe I want to, in addition to these two links, also store information like who created the association, at what time was it created, does it expire? There's all sorts of other kind of metadata or meta information about the association itself that you can encompass or encapsulate in a resource to represent that information. And also additionally, because it itself has its own identifying URL, if you wanted to delete that association, you could execute an HTTP delete to that resource's endpoint, and it would delete just the relationship. It doesn't delete the account or the group, just the connection between the two. So it's a very flexible, very powerful way of associating things by representing them as their own resources. Sometimes I've gotten questions, what if I don't want the actual meta link, the resource relationship objects themselves? What if I just want the groups? I don't care about the actual membership entities. And so there you can actually create two different properties. One is the groups, the other one is the actual group memberships, and the client can choose what they want to consume depending on their needs. Maybe they don't care about the metadata between the associations and they just want the groups. Errors, how do I represent an error? Something goes wrong when I execute a request. And the idea here is that we want to be as descriptive as possible, right? We want to give the developer as much information as we can so that they know how to debug, maybe self-service, so they can take care of the problem and be on their way and back on a developing application. Nobody likes having to wait for answers from a support team so they can move on with their day. So developers are your customers. We want to make things very, very clean and easy to use for them. So I got to give a shout out to the guys at Twilio. They kind of spearheaded this approach with their API, and we've seen other companies adopt it. Stormpath has also adopted it. But the idea here is that we're showing an error response that contains a bit of information. In this case, it's a 409 conflict, like something cannot occur on the server because something else already exists. And so in this example, we're returning a resource with the HTTP status code included within it. And the reason why we do that is so that the client doesn't have to go to two different places to get this information. Yes, it'll be in the HTTP headers, but they can get everything they need to just in the response body if they want to. We have an internal code that is specific to Stormpath's API, and the reason why we do that is because the HTTP spec only has, something like 24, 25 error codes from the 4xx range to the 5xx range. And if you think about it, that's not a whole lot of codes to accurately represent error conditions or reasons why something failed. So in addition to the HTTP status code, we also provide an application-specific code that gives them a lot more information of why the request failed so that they can go resolve that problem themselves. Property in this case represents the particular property that caused the problem, so they know that when I submitted this new directory, it's the property, the name property is the reason why the request failed. And the message property or attribute is pretty interesting. It represents something that you can directly convey to your customer's application end user. So what I mean by that is if your customer is a developer and they call you, this message, they can take this and immediately relay it like in a user interface to their own end user. And that's really nice from a usability perspective for your customers because that's just that much less work that they have to do in order to show their users some meaningful information. So by this, if they just take that and relay it to the user, they don't have to translate this message or take this very developer-specific message and convert it to something that the user can understand. You can give them meaningful information right away. And the developer message, of course, is something that the developer customer would actually understand. Maybe it's information that tells them how to fix that particular problem that's not relevant to the end user. And you can provide a more info URL. This is nice because it's a normal HTML-based web page, and you can give them all sorts of good things, links to support forums and knowledge bases and help links and all this other good stuff to give them more contextual information about how to solve their problem. I got a couple minutes left. Let me run through security really quick. Obviously, we're a security company, so I want to cover it. Avoid sessions if you can. REST architectures are supposed to be stateless on purpose to help with performance and scalability. So most people authenticate every request that comes into the server. And they do that usually with various different standards. You should authorize actions or behavior based on the content in the resource, not on the URL. URLs can change, right? You can have redirects, you can put them on different locations. But if you actually say that, oh, sorry, you're not allowed to execute this behavior because the specific account you're referencing is not accessible to you, that's a much cleaner security check than just saying you can't go to /accounts because it's contextual. It's security. It's based on real data, not on how you access that data. That's a really important distinction for security. We recommend that you use an existing protocol. So most REST APIs these days will use OAuth 1.0a, OAuth 2, or even HTTP basic, but only over SSL. It is never secure. It is never a good idea to use HTTP basic over plain HTTP connections, and that includes intranet corporate environments, because this data can be parsed via log messages, and maybe there's errors and they put the data in the logs. That information then is now captured in the logs, and it could be interpreted or intercepted. So even in corporate environments, always make sure you use SSL to transmit this stuff. Only use custom authentication schemes if you really, 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 really know what you're doing, and only if you provide your own client SDK. So at Stormpath, we're crypto people. We have our own custom authentication protocol. It's very similar in a lot of ways to OAuth 1.0a, but it's actually more secure because it guarantees authenticity of the request payload, which OAuth 1.0a does not unless it's a form post. So there are reasons why we did that, because the data is very secure and sensitive in nature. But we know how to design these kind of algorithms. We have crypto people on staff. If you're not that comfortable with these things, use OAuth 1.0a. OAuth 2 is also a good approach. It's not quite as secure as OAuth 1.0a. I can explain that to you guys if you want at the end of the presentation. I'll give you all the breakdowns of why. And finally, we recommend that you use API keys to give to your customers that access your API and not usernames and passwords. There's a whole lot of security reasons around entropy and the complexity of password keys and some really good techniques or good reasons of why that's from a security perspective beneficial. But ultimately, the most kind of obvious one is that if your customer uses their username and password to configure their REST client to talk to you, and now they go into the user interface and they change their password, now all of their REST clients break. So you don't want that to happen. That would be a really, really bad side effect. So use API keys to give to your customers so they can authenticate with your REST API. Very briefly, 401, 403 are codes that mean unauthorized or rather unauthenticated. So 401 means you need to give me some valid information so I know who you are. And a 403 is I know who you are. You've proven to me that you are who you say you are, but you're still not allowed to access this particular resource. So make sure that when you return these status codes, you get them correct. HTTP authentication schemes, we don't really have time to talk about that now. I can talk to you guys if you want to come up afterwards, and I can talk about how this stuff works. IDs are opaque. They should be the href. You could support method overrides. Maybe legacy clients don't know how to interact with anything other than post and get methods. So if via a post only, you supported this underscore method equals delete or underscore method equals put, you can obtain or achieve the same results within the server, but it's important that it has to be over post, because post means it's a server processing directive. There should not be any caching of this. Caching and concurrency control, this is important for optimistic locking. There is this notion of an e-tag header that essentially represents a version stamp of that particular resource, and the client can then later request, hey, has anything changed for this particular resource? And the server can respond with a 304 and said, nope, the version of that particular resource has not changed. You're good. You don't need to execute the full request. This is really powerful and used by HTTP caching servers. And this is kind of what makes a lot of the web stuff faster, because they can leverage these caching capabilities. Almost done. Maintenance. If you need to maintain and change your REST API over time, use HTTP redirects. Maybe you do want to change the URL for a particular resource, and that's okay as long as the data format itself doesn't change. Clients should be expected to know how to process 302 redirects and then access the new resource location. So if you need to do some API maintenance or change the location of where things reside, that's okay. Just make sure you don't lose that link so you can redirect your customers. That's everything. Okay, thanks for your time. Take care. Enjoy the rest of your evening.